Hey, Algebra 2, we are going to go over day 2 of 6.2, combining like terms. You've done combining like terms a lot ever since Algebra 1. You do it all the time when you add 3x squared plus 2x squared and get 5x squared. But it gets a little bit more complicated when we have our fractional exponents that we started in this chapter. So I just want to go through some examples with you to make sure you can tell what the coefficient is and what the base is and what the exponent is. So you can see that I've got a big picture of fruit, and I've got define like term, has the same base and the same exponent. And I have 3 examples already written down badly because writing on the little screen is hard. But I've got x squared and 4x squared. Those are both like terms because x is squared, and that's the base x and the exponent 2. And here's x and it's squared. Over here I have 1 of these, and here I have 4 of these. If I added them together, I would have 5 of these. So I just want to point out some things. I'm going to define coefficient for you in just a sec, as a reminder. This next one, this is again an understood 1 in the front. I have 1x to the cube root, or the 1/3 power. Now over here I have 4 of the same thing. I have the base of x and the root of 3, or x to the 1/3. Written this style, in this third example, I have coefficient of 2, 4 to the 1/3, minus 3, 4 to the 1/3. How many 4 to the 1/3 do I have? I have -1, 4 to the 1/3. So I want you to think about these like fruit. So maybe x is an apple. And if it's squared, it's a green apple. So you're going to count up how many green apples you have. If it's to the 3rd power, it's going to be a red apple. If it's to the 4th power, it's going to be a gala apple. So you could define them being different because they have something different, a different base or a different exponent. That's why I have a picture of fruit here. Because sometimes I say I've got 1 banana and I've got 4 bananas. The bananas are the same. So altogether I have 5 bananas. And by banana, I mean it's exactly the same. It has a base of x and it has a root of 3. So let's define some things here on paper. So I've already written it down, but you need to make a note that like terms have the same base and the same exponent. So here if I write down x to the 1/2, 3x to the 3/2, 5x to the 1/2, 7y to the 1/2, -3y to the 3/2, and 10x to the 1/2. If I look at that list, I only have 3 terms with the same base and the same exponent. So the things that I can combine or add together or subtract from each other are only things with the same base and the same exponent. This is the combining part, adding or subtracting. So let's see. I can say x to the 1/2 plus 5x to the 1/2 plus 10x to the 1/2. And here I have a quantity of something. So I have the like term, which is base x, exponent 1/2. So basically I'm saying, okay, x to the 1/2, I have 1 of them, this is an understood 1, plus 5 plus 10. I have 16x to the 1/2. You don't have to write it this way, but it's a way to think about adding the coefficients. So here I have coefficient of 1 coefficient of 5, coefficient of 10. And coefficient tells the quantity of that term. Okay? So you need to be able to tell what the base is and the exponent, and you need to be able to tell the coefficient of those. Let's go through some of the examples so that we can make sure we're not confused about the fine points about this topic. It might seem like it's so easy, why is she going through this? But it also can be easily confused. So I just want to be very particular about it. So let's do example 34 from your book. This is on page 424. It says 25, the fifth root of 2, I forgot already, 34, 25, the fifth root of 2 minus 15, the fifth root of 2. So, do we have any terms that have the same base and the same exponent? Well, this is the base of 2. So this is base 2, and this is exponent of 1/5. Remember, the root goes in the denominator. So all three are the same. All three are like terms. So therefore, we can actually subtract. And we only subtract the coefficients. If like terms, subtract the coefficients. This is like saying I have 25 watermelons minus 15 of the same kind of watermelon. So altogether I have 25 minus 15, which is 10 watermelons. But they have to be exactly the same kind of watermelon. They can't be like seedless and seeded. They have to be exactly the same base and same exponent. Let's try a more complicated one. So this is number 40. Another even one. You have odd for homework. So 40 says 5 times the third root of 48 minus the third root of 750 minus the third root of 750. So what do we do with that? We have 5 watermelons, and then we have subtract 1 grapefruit. These are not the same. How will we add them together? Well, we're going to have to somehow figure out how to make them the same fruit. And we're going to do that by simplifying each one first. So in this step 1, these are not like terms. I really can't write terms for some reason. There. They have different bases. And you need to be able to sort of figure that out. These have different bases. So here I'm going to simplify the fourth root of 48. I can only take things out if they're in sets of 3. So let's look at this. This is 5 times the cube root of 16 times the cube root of 3. 16 times 3 is 48. So I'm going to be able to simplify this sum. 750, that's going to be subtract the third root of, let's say we have 75 times 10. Is that helpful? 75. It's a little bit helpful. So this is my trying to get common base. Right here, this is 5 times the cube root of 8 times the cube root of 2 times the cube root of 3. 16 is 8 times 2. I needed to go that one more step because 8 has a cube root. It's 2 times 2 times 2. And I needed to separate it down to be able to figure that out. My second one is the cube root of 25 times 3, cube root of 3, times the cube root of 5 times the cube root of 2. I simplified 75, 25 times 3. I simplified 10, 5 times 2. And that's helpful because right here I have the cube root of 25 times 5. That's 5 cubed. That's 5 squared times 5 to the first is 5 cubed times the cube root of 3 times 2 is 6. There. So that was helpful. I already said 8 has a cube root, so I can write it like this. 5 times the cube root of 2 cubed. The cube root of 2 times 3 is 6. So I'm getting closer, and this is the long way to do it because I'm trying to show you how to work the problem. You might be able to do this quicker, and that's okay. So here I've got the cube root and the cube power cancel. I have 5 times 2 times the cube root of 6 minus 5. This power and this root cancel each other out. This is 5 to the 3 over 3, or 5 to the 1. This is 5 times the cube root of 6. Now I have the same base. Yay! Same base. 6. Same exponent. 1/3. And now I can add them together. I have 10. The cube root of 6 minus 5. The cube root of 6 is 5 cube root of 6's. So simplified, I have now gotten the same base and a quantity that go with it. I can say I have 10 bananas minus 5 bananas because the bananas are the same. 5 cube root of 6. My fruit reference might not bring you joy, but it's a way to explain it. Okay, so this section you're going to have to simplify in order to add and subtract them together. You have a section that's very similar to powers, rules that's coming in your homework. You're going to have to simplify like I did here, where I found the factorization of something so that I could take things out. You can only take them out if they have the same quantity as the root. So you have some simplification there for part of your homework. And so I hope this was helpful. You should have notes to upload with your homework. I need for you to do that every day. As you follow a video, you need to take notes. Upload that with your assignment. And that's it. Thank you.